good afternoon, everyone. We'll get started. Welcome to PARC Forum on Monday, May 5th. I'm Amy Hauman, Senior Director of Marketing here at PARC, and it's my great pleasure to welcome you to what should be another provocative conversation today. What happens when design and tech innovators team up? The goal of this partnership was really to look at one of the early stage technologies that we're developing here at PARC, printed electronics, and to really start to tell the story about how companies can think about an early stage technology of this nature and how they might innovate with it. We know that the user experience of interacting with technology is so important, so we decided to partner with Smart, who brings, as a design agency, a deep understanding of how individuals interact with technology. So we wanted to come together to illustrate in a very tangible way how companies might start to think about printed electronics and early stage technology and how they might think about how it has use for their users. So today's panel, I'm very pleased to introduce our moderator, and hopefully I'll get it right, Connie Guglielmo from CNET News. She's editor-in-chief. She's been covering technology in a variety of different outlets for a long period of time, and she's very excited to be here today and moderating the discussion. From Smart Design, we have Dan Saffer, who introduced himself as the son of a plumber and a psychologist, which he brings together both those disciplines in his role as creative director at Smart Design. He is presenting with PARC's own Janos Veras, who is the program manager for printed electronics here at PARC, a long background in material process and device technologies. And last but not least, who will be kicking things off tonight, Mike Kuniowski, who's a user experience designer, researcher, and author, and he's also from the PARC team. So without further ado, I'll turn things over to Mike to get us started.
All right. Thanks. I guess since I'm unwired, I'll just walk around. So let me give a little tiny bit of my background. So I'm a user experience designer. How many people here don't know what a user experience designer does? Awesome. That's finally that barrier has been crossed. So what I've been doing for roughly the last 20 years is looking at technologies and looking at what people need and trying to, or people want also, and trying to pull those things together. And essentially the process of design is that process of essentially understanding people, understanding the possibilities of technology, and bridging the needs and desires of people with the capabilities and possibilities of technology. Now, one of the things that my group does at PARC, which is the Innovation Services Group, is that we're essentially kind of PARC's consulting arm, and that we work with our commercial clients to try to identify the spaces where PARC's leading edge, bleeding edge technologies that may not necessarily have market examples that can demonstrate specific places where they're applicable. And we try to identify where there are market possibilities and where there are user experience possibilities for those technologies. And one of the things that's quite difficult, and one of the challenges that we often run into, is that because our technologies are completely cutting edge often, there is this infinite possibility space in which you could use this for anything. You could use it to pick your teeth. You could use it to mortgage a house. And everything in between. And so what we have to do is we have to understand where the interesting possibilities are. With printed electronics, one of the specific aspects of this as a technology is that as a hardware technology, hardware technology, it has essentially a particular barrier in that traditionally hardware technologies have been developed and marketed and sold by people who have an idea, then they get someone who has a lot of money who can support them doing the build out of that idea, and then essentially making up an application and then going out into space and trying to see if it works. And then if it fails, and most of the time it fails, kind of trying to go and move on and try to find another application if they still have the money. This is a very brittle way of developing technology, and this is why actually most of the hardware that you see out there is actually quite conservative in its development. Like most of the hardware products that you have seen today are actually very conservatively done. They're using essentially iterated versions of fairly old technologies kind of in the technology space. So when you're entering within essentially a brand new set of technologies and a brand new set of ideas, it's very hard to get purchase out in the marketplace and understand where can you apply that. So one of the things that we wanted to do is we wanted to explore that space. Before we went out and tried to do the big arc of let's go and manufacture a solution and then try to hire some marketing people who will try to find some people who might want to buy that solution and then evaluate whether it works or not. We're bringing some of the notions that were developed kind of in the lean startup world and in the kind of agile software development world, and we're trying to, and of course in the user experience design world, and trying to bring that to the notion of thinking about a brand new, fundamentally new set of technologies. And so what that meant in the case of this project was exploring a wide space, evaluating it, and then deeply exploring one of the possible tendrils in that to try to understand where the possibilities are, where the places are that we shouldn't go, where there are places are where there may actually be some really interesting work to be done, and using that as the platform to set our next stage of research. And I think with that, I can hand it over to Janos.
So one thing I wanted to give you is a flavor of what printed electronics is about, and get you an idea of why we're excited about this topic at PARC. And traditionally, we've been trying to sort of invent the future. That's been our mantra. And printed electronics, we think, is a big deal. It's a significant opportunity because it touches on so many technologies and brings together several fields. First of all, we have the way we operate is work with client companies. We don't commercialize any of these technologies that Mike talked about ourselves. We help other people to do their technology better and find applications for them. So we work with material companies in exploring how we can develop functional inks, so inks that do a little bit more than just give you color or shapes, and they're really interesting. This is a field that is early stages, and I'm holding here a couple of semiconducting materials, some conductive materials, dielectrics, and materials that are suitable for sensing. And this is really just at the early stages, and the opportunities are endless. So nanomaterials, organic materials, the range, the scope is infinite, and it's really exciting for material companies. Then there is this idea of if I use these inks and I put them into printing machinery, so can I use print as a manufacturing technique? Starting with processes are fairly conventional. Can I use, extrapolating a little bit, can I convert a printing press, which is losing business today because we're not using books, we're reading everything on the screen, can I use it for something else? And that's an exciting proposition for people who are in the business of print. And then the next question is, what can I make with it? And so that's where the ranges, you will see, that is very broad. So today we're exploring the space of printing smart labels, where barely a sensor or a few bits of memory give you just enough functionality to make that proposition interesting and give added value to the printing process. But beyond that, we think it's going to go a lot further. By using electronics and sensors and printed batteries, we think we can make it a lot more complex. And the ultimate goal is to basically add intelligence to additive manufacturing. This touches on 3D printing, the idea that if you add now the plastics that you see or metals being used in 3D printing, add to that a level of complexity and enable to print functionality. So literally electronics, and that's probably the most important. Then beyond that, actuators, there's many, many layers to that. But basically, you make additive manufacturing, which is very interesting for many, many people. It's getting into manufacturing today. Add to that more new layers of complexity, more layers of value. And the big question is, of course, what is it gonna be used for? Even 3D printing has got this problem, this challenge of, what is it that we're gonna exactly make with it? We understand we could make anything, but what that thing is going to be. And that's why we teamed up with Smart, because that ends on the question of, how does it make sense for people? So we really figured out that we had to do it together with people who are in the business of design. So one thing that may be useful for you to see that some of the early implementations of this idea of using print are already happening. This is an example of a roll-to-roll printed circuitry. So we're printing already memory devices that are going into brand protection. That's the simplest functionality. The next level beyond that is the kind of smart labels that you see there that detect, say, if the product has gone above a certain temperature range, and then in the supply chain, you can monitor that. But we're talking about very simple functionalities. Those are feasible today, and we want to increase that by adding more and more layers of electronics. And ultimately, we think it's going to go pretty high in functionality, and the question is where we're going to use it.
Right. Oh, and so that's where we came in. So. Smart Design we're a design consultancy. We were founded about 10 years after Parc was founded in an apartment in New York City by industrial designers, and we're probably best known for our kitchen utensils. All the OXO kitchenware is all Smart Design. So probably a lot of you have it in your homes at some point, and. About 10 years ago, we started to get more and more into the digital space as hardware and software started to combine. And this project is really the ultimate in hardware and software starting to combine and being a material. And what we're really good at is bring meaning to technology. And to things that people have just come up with, whether it's a new kind of material like glass or printed electronics, or just converting a new business model or a new idea into something that people are going to want. And design these days has become kind of one of these core pillars to start to bring new technology in and get it to have it help adoption, have it help customer loyalty. Have it make it understood, have it give it meaning to people. And those are all things that I think are really important, and we've seen over the last couple years the kind of importance that design is now bringing here to the Valley. So, and the project that we are on here is a really fascinating one for us. I mean, it's as Mike was saying, it's very unusual as a designer to get your hands on technology that is this kind of new and this kind of exciting, and the constraints that it put on us were really interesting as far as what kinds of things could this be good for? Something that exists in this land that's between a QR code and an RFID tag. Like what is that space? What could it be good for? So what we did is we had an engagement here where we came down and we first of all we kind of immersed ourselves in the technology. What is it that this technology could do? What were the constraints that we had? And then we tried to figure out, okay, what are the goals that Parc has and the goals that Smart has? And Smart, we have an interaction design lab that is basically set up just to do these kinds of projects and to kind of bring new technology to light and see what we could do with it for ourselves and for both of our clients. And then we went into an ideation sessions, which lasted over a period of a couple weeks, some here, some back at the Smart offices. And there was a number of different big kind of areas that we ended up exploring and looking into. Everything from transportation to logistics to entertainment to supply chain and smart packaging, thinking about things like how it could work with everything from greenhouses to the Internet of Things to being embedded inside your car to being displays on your windshield. And then we started to really focus around wearables, because one of the great things about this technology is the ability to make these very personalized, print these very personalized objects. And so we started to focus a lot around wearables and around wearables and health in particular. Because some of the things that we thought would be really interesting, riffing off the things that are already happening around the smart packaging, was around how do we create smart monitoring for human beings as a patch that you could wear, and then some kind of smart medicine dispensing system that you could also wear as a patch, so that your local pharmacy could print you out a patch with the medicine that you have and put it on your arm, or your doctor could print out a patch to check your, if your heart has got arrhythmia, and you could wear this patch around. So just some of the different areas were really fascinating. But that was the one that we dove into, just because it is such a human story, and that's kind of the thing that design does really well with technology, is bring out these human stories, these human needs that then the technology can supply.
And from our perspective, we really wanted to make it, well, I'll let Janos talk about more about it, but we really wanted to take advantage of the unique properties of this technology. We really wanted to emphasize what printed electronics, which is essentially this alternate universe from the silicon electronics that everyone knows. And I think as Janos has told me, like basically we are, with printed electronics, roughly where silicon electronics was in the early 70s, but we're on a similar trajectory. And so, but in an entirely parallel universe.
So it's important to state, of course, it's not, the goal is that this technology is not to compete with silicon. It gives you something else. It's basically more about print is good when you do electronics on large areas, or when you do it on demand, or you do it, make it conformal, or three-dimensional. So it's not about creating some kind of competition to silicon electronics. It's about distributing electronics on larger scale. So the applications that you see here, the best fit is where you make something larger, where the sensors need to be distributed, where the device needs to be made on the spot, and it is part of additive manufacturing. That's when it becomes really exciting.
Right.
So it's going to be a parallel thing to silicon, and potentially even involve silicon, not rather than compete, but combine and build on each other's advantages.
Yeah. Right. Because
even though the processing power now is around a 1960s calculator,
right.
What happens is when that is distributed everywhere, when everything can be a 1960s calculator, that's a real game changer.
Right. Yeah, and for example, like Janos has this role of electronics. To make a circuit board, to make a traditional circuit board 70 feet long would be incredibly prohibitively expensive. But with print, it's basically free.
So the idea is that the kind of functionalities we'll be looking with the roll-to-roll techniques is, so you imagine you've got on your everyday packaging a barcode. The question is, what is it that I can add to it with minimal cost that is just a little bit more smart, more intelligent than the barcode? So the number one thing is memory, printing memory. 10 bits of memory, which nobody would have thought that it's actually useful. Turns out it's really powerful for brand protection. You can actually encode a fairly large number in 10 bits. And so you can put in serial numbers, you can track how many units, how many times the product has been used. And then, so that's where it starts. It doesn't need to be rocket science to get into implementation. So those kind of things are already happening. And I'm sorry, but then the question is, how far can we take it? And where is it that, despite, it might be difficult, but how far where should we push the technology?
Are you done with your presentation?
Yeah, sure.
Yeah.
Go ahead.
Yeah.
So you can tell these guys are very excited. I don't know if you can hear me. Very excited about this technology, but first of all, thank you all for coming here, and thank you for our speakers for taking the time to talk to you. I want to step back and just ask you a question that I, as a reporter, and I'm always the cynical person in the party there, learning from each other, this idea that design should inform technology and vice versa, you made it sound like it's such a radical concept. How radical a concept are we talking about? To me, that's something that you would think is a very obvious thing that people should be doing. Why wouldn't you be collaborating and talking to each other. Why create things in a vacuum? So you started out by talking about that, so I'd like to understand how radical that thinking is.
I mean, so I've been involved in one form or another with this for about 20 years. PARC has been involved with thinking about kind of the intersection of people's needs and technologies since its inception. But for most companies, especially in Silicon Valley, the notion that you're bringing design in as a core competency is actually quite new. I would say really within the last 10 years has design become a core competency where you've gotten startups with design founders. You know, it used to be that you had like the technology founder and you had the product founder and maybe you had the business founder. Now you're also getting this fourth pillar or third pillar of design. And I think it's because technology was so, the technology industry was so technology driven. And so the thought was, if we can just make the technology and push it out there, we'll figure out a use for it. And then what happened is that people realized that design is actually a risk management technique. That essentially by using user experience design, you are reducing the risk of market failure. And that has actually, I think, become increasingly embedded in people's thinking as a way to both manage the risk and create products that have potentially validatably in some way products. When you have a product that's successful, if you use user experience design techniques, broadly speaking, you will have a much better idea of why it's successful because you understand much better about why people bought it and how they used it.
Dan, so, what do you think about that?
I mean, for me, you know, I think for a long, as Mike was saying, I think for a long period of time, it was very difficult to make things happen, to make things possible. And I think over the last 20, 30 years, we've started to get a number of things that are now trivially possible. And so there's a lot of things that you can do. There's a lot of things that can be combined without there's a lot of things that can be combined to make kind of these commodity products that then need some kind of design to make them into things that are meaningful. When you're dealing with these kind of deeper technologies like printed electronics, I mean that stuff takes a long time to even get to this level of maturity. And I can see why for a long time design and engineering were farther separated because it does take, I mean there's just a lot of issues that technologists and engineers have to solve before they can even get to a point where design becomes valuable. And at the point where design becomes valuable is at that point where you start to say, what could this be used for? How could this be helpful? Who's going to buy this? When? Those kinds of meaningful questions. So.
Okay, I just think it's very, very interesting that is something that you've had to arrive at, which seems very obvious to someone who's not a technical, or I'm not an engineer, I'm a reporter, right? So.
Connie,
Anyway.
one important aspect of this that, yes, I mean, people, of course, they apply design in technology. I think what we are trying to do is apply it early. And no matter how difficult it is, I mean, it's, you know, if you think back of what happened with computers, so a lot of early computing happened in this place, you know, a few decades ago. People, you know, those guys thought about how computing would touch our lives, and you're going to be carrying a computer all the time. I mean, that sounded impossible, you know. So that's an important thing, is we need to think of those things and not to be afraid of it's difficult. It's very difficult, but you know, well, let's think of difficult things and let's dream, not to be afraid of dream. That yes, I might be able to have it made on the spot for me in the pharmacy, or you know, have a car which I can custom make components for.
Let me just ask you one other question about design before we move off of that, and that is additive manufacturing. I talked to some folks at Corning last year, and they talked about their process, which includes creating the factory equipment in tandem with the new materials they're creating, because they need a way to produce what it is they're coming up with. And so I'm curious about, as you're going through this design process and engineering process and talking about it, you've mentioned additive manufacturing as being a big area of opportunity here, and I'm sure a lot of people in the States would love to see that manufacturing happen in the United States as well. Where is the design thinking around that as part of this process?
So going back to the manufacturing part, we have a lot of background in printing, which is additive manufacturing, essentially taking those inks and putting into a variety of printing processes. Today, from the technology standpoint, we don't know yet what composition, what sequence, or their combination of printing techniques will do the job. And there won't be one. So you see a lot of additive manufacturing labeled, oh, this is additive, this is additive. There are many techniques, and what we find important is figure out what the combination of those that will lead, especially not just the additive core, but what I'm most interested in is how you make it, you know, a level up from what exists today. So printing plastics and metals, that's going well, and 20% of that is apparently going already into manufacturing. But that next level of how we add to that intelligence is a really difficult question, a really hard one. We think it makes sense. It makes totally, it's a game changer altogether from the ordinary plastic objects that you see most of the time. Now, you know, so what does it mean? So the question I would put from the design for the designer is, and that's what we did with Smart, essentially, imagine if I have an additive manufacturing platform or a printing platform that lets me print on demand, not just a plastic cup or a figurine, but something more complex that has electronics on it, in it. Yeah. And you know, so let's not be constrained about how difficult it is, how many components, will it be an iPhone? I'm not sure if it's going to be an iPhone, but that's, you know, so that's the question. So if I have that capability, which is the technical, you know, it can be done, we think it can be done, then what should I use it for, you know?
I think an interesting example in that space in terms of what we learned from that process is that, so we kind of started talking about that. Like, let's say we want to print this. You know, it's still a long ways away. Let's say we want to print this, and some of the renderings that Smart came up with essentially looked like MakerBots. And then Janosch's team, like, they came back and looked like kind of a pretty MakerBot, and they were like, no, it can't possibly be that way. And we're like,
although it might.
Right, but you had a lot of like very legitimate, like, why can't it look like a MakerBot? And they started saying, well, it can't because of this and this and this and this. Like, there's all of these other kinds of qualities and constraints with this material that won't let it look like a MakerBot. And so we're like, as designers, everyone's like, oh, so it's going to look like something else entirely. So now we kind of have some idea of where the technology is going and why it can go there.
So let's talk about the conversations that you had as you were ideating, or whatever the word is that you're using, brainstorming, eating dinner, et cetera.
Right.
Yeah, it's always, there's
Sticking
always food,
Post-its up.
right?
This is what we do. Just stacks of Post-its.
Yes.
So you decided to look at health, you know, and I'm sure you had some obvious ideas. Wearables are a very hot topic. There's a lot of conversation about how we're all going to look like the Borg in the next 2 years. What was one of the things you rejected right off the bat?
Oh man, I'm trying to remember. If we look at some of the, we have some of the things that were, rejected.
So, I think we rejected like the wristband as a concept.
Okay, that's very interesting. Why is that?
I think because we had this like, well, if we're going to custom make this for everybody, then and one of the qualities of this material is that it can be really conformal to the body. Then the wrist is actually not that interesting. There's no reason to make a wristband. Like, maybe you need to put some different sensors or firmware on there, but it's not going to really be a wristband. So if it's not going to be a wristband, what's it going to be?
So did you have this conversation with Nike? Is that right?
Right.
Okay, so it's not going to be a wristband. I think that's very interesting, and I'm curious to see what comes out this year, because there's a lot of hoopla about things coming out in that direction.
I mean, as a designer, I want to say that I think there's legitimate things to do with wristbands. I think the thing that you're going to see is they're going to turn into bling, but that's a separate issue from what we were looking at.
Okay, so let's talk about, again, what you rejected the wristband. What was the leading decision? I mean, I know you have this design, so let's talk about how you got here.
Well, one of the things that we were really trying to do is like, what could we, as kind of one of our goals for this was like, what could we do to show off what this technology, this specific technology could do? So things like the wristband, they weren't that exciting,
right?
Because they're you can print a wristband. It's not that.
Although I must say that in the evolution of what type of wristband you want to make, the ability to prototype and cycle through ideas additive experimentation is really powerful. So that alone, so there will be many products, wearables, which are made by the million, and they're going to be exactly the same for everyone. And there is this other range of them that you might want to customize, whether it's for fashion or for a particular condition. So I think those categories too, and additive has got a huge advantage in being able to accelerate the development. And so one of the reasons is that many of the sensor technologies that could go into this, they're really amenable to printing and that combination. There won't be one sensor. So today you have, today in a wearable device, it measures your heartbeat, measures your blood pressure. I mean, it's going to be laughable probably looking back a few years from now, how little we were able to monitor. So it turns out that from your sweat alone, you can deduce about 185 different biomarkers that can indicate whether you're under stress or not. So it's just that how many, what combination of those and how you're going to be making them is wide open. So that cycling through ideas is very useful for just the prototyping stage. And there's this other area.
Yeah, Dan, talk about what you found. What some of the interesting, unique uses that you could personalize here.
Well, some of the things that we were that we had been thinking about were things like fashion and stuff like that. That you could, for instance, you could print a specific kind of bracelet that wraps, all the way around your wrist and did very specific things. Or you could have, very specific tickets that this ticket is for you and you alone because it's keyed to you. Stuff that would just be prohibitively expensive to do right now. I don't know if you have any of the other great.
Well, yeah.
I
mean, within this space, and we had a lot of things. I think one of the things that really caught us, one of the things that really grabbed us about the kind of delivery of medicine aspect of it was a combination of, I think, several things, but one of them is Janos's group and Parc in general has actually a fair amount of capability in microfluidics, essentially moving fluids around, like essentially printing things that help move tiny amounts of fluid around. And that was interesting. And essentially printing things that move tiny amounts of fluid around. And then the second one was essentially this notion that you could create a custom set of sensors, as Janos was saying, out of these either biomarkers or various other things. You could say, well, we want to track a specific set of qualities about this person. We don't need to quite do all of this, but we can track this very specific set. And that might be different from person to person, from condition to condition, and from situation to situation. And that started to seem like that was a really compelling use of this, where it could be really uniquely valuable for that.
So how real are we talking about in terms of a time frame for what you're doing? Mm-hmm. You came up with some ideas for what is possible. I know that Parc does not take these technologies to market. You're looking for partners to commercialize it. Right. Are we talking about Star Trek vision of the future, or are we talking about things that we'll see in 3, 5, 7 years? So
let me show you a couple of things that, so where it stands, that demonstrates. So first of all, that is the printer you see there, which is, that's how it looks like. That's why it's not exactly like a MakerBot. But we have a couple of projects where, I would say.
Should I point to it? I don't know if people understand.
Yeah, so that's the bottom, this engine, so it's very complex. It's constantly changing. We're putting on different kind of printing techniques. And so we have a few projects where we're starting to explore what you can make with it. So one is a mouse guard, a printable mouse guard. And we realized that we could make it with fairly standard processes too, but it's just a nice vehicle for us to explore, where it's a proposition where when you make the mouse guard, you can make it 3D shaped, so you can address the customer.
Mouth guard.
Mouth guard.
Yeah, it's for sports or for the military.
So it can measure, for example, lactose in your saliva. So this is an example where you might want to customize the form factor and you add the sensors to it. It could be made many other ways, but it's a vehicle for us to explore, how to make it. So that's where we are. We are not commercializing it, but it lets us show people that, you know, this, we kind of can build a prototyping platform for this. And then another one is a shoe sole, and many other people do this in different techniques. But again, for us, it's a prototyping vehicle to play with ideas where we can additively create the shape of it and add to it the electronics. So they're really basic examples. These are early examples. And the way we're going to do this is we need these pilot projects in a way to show people that it's realistic and, you know, what can you do? And that's how we engage, you know, with the end users. So
I'm curious what role you think Kickstarter and other crowdfunding kinds of platforms, you know, that's been the big switch in technology. It used to take, you know, $100,000 or more for somebody to start a company. Now it can be two guys. Unfortunately, it's always two guys. No offense to guys. In a garage with $10,000 and, you know, minimal equipment. Is this the kind of technology that we can see them experimenting and playing with in those garages?
Yeah, Janusz was looking at me because I've done a couple of Kickstarters on my own, or my little hardware company has done it. I don't know, Dan, if you want to jump in, I will.
You're the Kickstarter guy.
Yeah, sorry. Yeah. So I think it takes a lot more than $10,000 to do that. Kickstarter. So my philosophy on Kickstarter is that the money you get from Kickstarter is going to be just a little bit less than the money that you actually need to have to make your first round of stuff. And that's counting your time as free. So the thing that Kickstarter gets you is it gets you two things. It gets you validation of whether your idea is stupid or not. And it gets you an initial set of customers that you can then sell more stuff to. And other than that, and so it's essentially a marketing and a market validation vehicle. I don't think for something that is designed for a broad consumer market, I think it is very rare to see Kickstarter be an actual vehicle for innovation. It is sometimes a vehicle for popularizing some specific things, but for every Oculus Rift, there are, you know, 10,000 little tiny iPhone accessories that either move the needle barely or don't move it at all. And so I think that you can count the number of actually innovative products that the Kickstarter has really taken off on, you know, both hands.
So that $10,000 figure doesn't come from me. Paul Jacobs of Qualcomm told me that's what he thought, given the cost of the sensors they're producing and how much you can get into a sensor now that costs less than $5.
Yeah, I mean, it's obviously possible to make these things, but the problem is, you know, the difference is making a thing versus making a business out of it.
Well, and that's what we're here to talk about, making a thing versus making it into a viable technology that's going to be widely used. But, you know, why don't we open it up to questions, because I'm sure you probably have more specific tech questions than I do. Yeah?
Manufacturing of devices, that makes sense to me. I can understand how you can print something that would be able to read that particular item. The manufacturing of a mouth guard or a sole, I can understand that because that's just physically a device that you could make and get it out there. But when you start talking about labeling somebody, as you have the label on the back of the neck, have you done any thinking whatsoever about how you're going to break through the inhibition of individual people who will be against trying to have something on themselves which may say that they're unique?
Well, let's make it clear that the label is not to uniquely identify you as a human being. The label is the equivalent of a prescription. So your doctor prescribes you a certain kind of medicine that is going to be delivered to you in a certain kind of way based on the sensors that are tuned to your body.
Or a monitoring regime.
Or a monitoring regime. And then you take that thing and you stick it somewhere on your body where it's either not visible or it's visible because you don't care. You know, think of a nicotine patch. And then so therefore the incentive for people to adopt it is that it is theoretically a way to get your prescription medication without having to think about when to take it or how to take it or what quantity to take it in.
And how are you going to manufacture that in Palo Alto University so I can get close to it?
So the idea is, again, this is a conceptual project. So the idea here is that we would partner with either a pharmaceutical company or a pharmaceutical company and a pharmacy chain to create devices that would go into the pharmacy that would uniquely, that would print a unique patch for every single prescription. Now, to your question, when is that going to happen? Well, we don't have those partners.
Right.
And so we're still in the early days of this.
Now, but so how the manufacturing is going to grow, how we're going to learn about this, is takes us through these kind of products. The things that I can print today, I can put it into labeling, say, products that you have in the supermarket shelf. That's doable. So we started the memory, we add to it sensors. That's how we learn how to print and how we add the sensors. They are not yet in healthcare. But that gets us into the game and helps us experiment, figure out what kind of printers we need, what's going to be the cost, how fast we can run the printing process. You see, we need to grow through those kind of steps. So we're not going to jump into that straight away. It's essentially we find the opportunities in advance of that. But I think it's really important that we start thinking about what happens when I can make more complex things. And even if they're difficult, say I can deploy it in more complex environments. So that's what the project is about.
I think your point is also that in addition to the design and engineering, some of these other issues, privacy, usability from a comfort perspective, and where that data resides and how it's used and who has access to it should also be part of the conversation at the outset.
Do you want to talk
rather
about
than
CCN? Mike,
okay, right here. Yeah.
My question is actually bringing it back down to the level of the printing itself. Thank you. So I actually print on textiles, which means that I violate my Epson printer warranty because I pass through it either cellulose or protein-activated dyes, fiber-reactive dyes. So I'm really interested in the printing part. I'm curious from just pure technology, you alluded to the fact that we've got all these printers around the world who could potentially be converted to this kind of printing. How far have you gotten with finding out, I've got an offset printer sitting in Mountain View, he's practically out of business. How convertible is this looking so far?
So, we work with a lot of companies who are in that kind of situation where we have printing assets or develop a particular printing technology. Now, I don't think that it's going to be a straightforward thing that's going to switch, you put in different things and it's a little bit more than that. So you do need to have higher accuracy printing machinery. You need to invest into some degree of cleanliness. But we do look at it as a different kind of setup. So the advantage is not unlike silicon, which has to be in a high degree clean room, the features are much bigger here, so it's easier. But you do have to make those investments, and it's not that trivial. So gravure printing is a really interesting because it's high accuracy. Flexo printing is good because it's conformal and it can address. It's a good one for packaging. So those are leading techniques. Screen, rotary screen, they are. So those are the techniques, in particular gravure, that gives you accuracy that we can print transistors with, we can print sensors with. But you have to make that additional investment of improving the accuracy.
I mean, there are actually, right now, it's a very different set of technologies than what Janusz's group is doing. But there are conductive inkjet printer cartridges or inkjet printing ink that you can get. There's been, actually there was recently a Kickstarter for that, but the ink is actually, the Kickstarter was for a specific Japanese company that's marketing it, but the ink has actually existed for some years. And so you can literally refill your inkjet printer with this kind of silver, it's literally like, you can talk about this, like, it's little like nano silver balls or whatever it is.
I think it's important that this is actually not on a Kickstarter level. These are the major chemical companies are looking at it as a strategic play. They're making significant investment in developing what you call functional materials that are in the category of conductive, semiconductive materials. I mean, out of that, you see probably on most of your phones, you've got OLED screens that came out of that development. They're organic materials that can emit light. So that investment is very strategic. It's most difficult for the printers to make that investment because it's really, you need to understand exactly the application. You need to know the volumes and how people will buy that. If you're building up a material portfolio, you can put it on a shelf and wait until that matures. Hardware investment is a different story. So that's why it's a difficult environment. We see the vision, really believe in it. The material guys are putting money into it. They develop things. The printing guys are struggling, understanding, and we together with many other people trying to dream up applications. And so this is a risky environment for anyone to participate. Our role is actually to minimize that risk, connect the various parties, and so what is the thing that you should be using in that for that particular application, and
It doesn't sound like your printer is going to be saved anytime soon.
but we can help maybe.
Danny.
You talk a lot about sensors. What about the actuation end? I mean, can you actually make, I noticed you said there was prosthetics, but what can you actually get out of printing that will make things
that's
move?
a really, really interesting question. There are material companies who, there's a company that was acquired not too long ago, artificial muscle actually from Stanford here, and they were acquired by one of the chemical companies. So, there are materials which, so polymer-based materials, piezo materials, and we're trying to be modest, so I think this is on our roadmap. So what Mike said about, fluidics is really interesting. Actually, we call this, the whole area is object printing. So how we print functional objects. It's not just about the electronics, it's how we put functionality into objects. And yes, part of that is electronics. Yes, part of that is optics. Part of that is actuation and fluidics, all of that. So that's going to be, more and more on top of, of these functionalities.
I think we were talking, Dan mentioned, we were talking about prosthetics as a really, like that is a unique, that is a thing that is probably needs to be uniquely tuned to a person. And if you print a prosthetic that actually has intelligence embedded in it and actuation embedded in it, you can start to see the possibilities of what these technologies can offer.
We have somebody in the back.
Hi, thanks for coming out and talking, and thanks for promoting the user-centric view of design. And as a UX person, the last year or so, I've spoken to an interview with a lot of startup companies, and to your point of you always thought design and tech go hand in hand, without exception, to all these startups, design is, I have a vision, you just have to implement it.
Right. Paint it blue.
Yeah, I like blue, make it blue. I don't know why this popped into mind, but 80–90% of startups fail. Random thought. But how can we, to them, doing user research to test a hypothesis of an idea, to build something, to discover what real problems real people face and try to build a product that addresses these issues rather than just their vision they had at business school. Sorry, business school people. What can we do what kind of language can we use? What kind of facts can we use to bring that it's worth taking a week or a month or going back and testing your vision? It seems like the startup VC culture is architected so that you have to be confident. Any showing of research is seen as a weakness and lack of confidence in your vision. And you have to just produce some slide deck that looks nice, and that's how you build a startup. How can we make things more useful?
Yeah.
Wow, there's a lot to unpack there. Yeah, I think the tide is slowly changing that way, and I think there's a lot of things about the lean startup and and lean methodologies that are all about how do we get something out and test it with people to see if this is something that they really want, and then if not, okay, we throw it away. Here's something else. So there's kind of that kind of try something, throw it away, try something, throw it away until you refine it in a way.
Pivot is kind of a
we'll pivot away from it.
Pivot is a current term for we did some user experience design and found out our idea is stupid.
Last week was the week that Mark Zuckerberg said that they weren't going to break things anymore, that they were actually going to be thoughtful about their design. And I won't even go there. But that mentality of, move fast, just break it, users will put up with what we're doing while we try to figure it out, might speak to your point that maybe there's going to be a little bit of editing before we see things. But I don't know.
I mean, but I think there's definitely something to be said about generative research and finding out what people are really struggling with and what they really need and what these unmet needs are and what, how could something like this technology really apply to those unmet needs. I think there's another way to come at it. And I think that there are some startups that are going from that. Hey, we've observed these 3 things that are bad and we're going to find the technologies to put this startup together. I mean, places like, Airbnb and stuff like that, they're doing those kinds of things.
I promote that and I give them examples and they always seem to have counterexamples of, well, Zuckerberg didn't do any research in Facebook. And granted it's confirmation bias, but they see that all of this great stuff as wasteful or delaying or anathema, basically. I'm sorry.
Yeah, I mean, I would say the argument is like, how much is it worth to you to fail? If you have enough venture funding to have an entire venture fail and then start again from scratch, great. Go for it. But if you want to manage the risk of that investment, well, then you should probably do a little bit. You should probably think, whatever. Measure twice, cut once.
Yes, thank you. The title of this program, I think, is what happens when technologists and design link up. So that's kind of a question and suggests that that's kind of a novel idea. As far as I can recollect, modern product design per se actually started around 1940 and has been going since. And so what does modern product design mean as against decorative arts and so on that were prior to that? Basically, it incorporated engineering feasibility or feasibility of manufacturing, problem solving, manufacturing, human factors and ergonomics, appearance and marketing appeal. So I'm not really clear which of you folks are the designers, or anybody can pick up the answer to this, but in what way is this concept any different from what it was prior to that point in time, which is still out there? So anyone that wants to pick up on that would be fine.
I'd say that I'd say that the pieces have been out there for a long time, but there's a difference in some ways between the kind of styling that designers did, like the Norman Bulgettis did at Studebaker, I guess, and which was styling for marketing and the kind of very, very user-centered design. So there was essentially this division between, in the old kind of design way of doing things. There was the people that did market research, focus groups came out of that universe, out of kind of the Mad Men era of that universe. And there was a kind of design, which was essentially kind of styling, which is that we want to make the Lucky Strikes logo be really evocative. And the two kind of fed back and forth, but they had very, very loose association, and there were very kind of long cycles. Like they had these 2, 3, 4, 5 year long product cycles. I think what's different now is that, and a lot of it was essentially driven after a lot of the engineering had been done. Like maybe they'd decide oh, okay, we'd like the little Landau window over here, and so we're going to need to reconfigure the stamping machine, and we'll do some engineering there. But I think that the fundamental shift is now the cycles are super tight when it's done right, on the order of weeks or months, and the designers and engineers are looking at the same problems, and often research, and so designers, let me make a distinction. There are people who do user research, and we have on our staff ethnographers who are, in many cases, the people that invented the notion of design ethnography, which is essentially going out before you have a product idea and looking at how people work, or looking at how people play, or looking at how people live, and identifying from that their needs, and then applying technology to that to solve those needs. Then there's designers who actually do the iterative process of identifying kind of what the technology is and what the needs are, and kind of iteratively making it so that they fit together. And then there are people who still have styling, who still do styling, who look at kind of what the emotional resonances are, and that's also part of the process, but it's a different kind of design. So I would say,
I think you'd find objection by any of the designers out there, whatever they call themselves at this point, because their collaboration with design, with manufacturing people, and with market research in terms of what the consumer might like or might want or use and so forth, that's been going on for quite a while. So I personally can't see that there's a distinct differentiation. You're just in another era. Your technology is far more advanced than it was, say, in 1960 or 70 at this point.
Sure.
It's still going. And there has to be a closeness. So I guess the proper question to ask, what even today, if you can identify it, is the common ground between technologists and designers? What is the one ingredient that you're both writing into or writing on?
commercial success.
Pardon?
Commercial success. I'd say that that's the thing that everyone's looking for. But I think that the difference is one of quality, of quantity, not of quality of work. That there's been a big collapse in terms of the disciplines and a tightening of the process. And I think that quantitative aspect of it is a fundamental sea change. But you know what? I've only been doing this for 20 years, so I don't know.
I think the common element is innovation, in my opinion, and has always been that. So,
I mean, I would also say, I mean, we certainly weren't doing anything that's like hugely novel here.
Yeah.
The novelty of it was basically at bringing design and technology in this earlier stage than it might have been years ago. I mean, if you look at things like touchscreens, which the first touchscreens were out in the early 70s, but it was a decade before designers ever got their hands on them, and several decades before they were into consumer products. So I think that's what's kind of unique about this collaboration, was just that time. I mean, one of my design professors once said, you know, hey, the history of design is really the history of materials, and this is just a new material for design to play with.
Okay, so is there a Moore's law in this new technology? And how many years do you think you will hit the density limit? And do you take the Moore's law, things like this, into the design thinking process? Thank you.
So this is interesting. Did you say density?
Can you repeat the question?
So one question was about the density limit. You mean when it reaches some kind of plateau or difficult to develop further? That's what you mean? And the second one is if there is any parallel with the Moore's law. So I'm not sure about the plateau, but so the way I think about the parallel with the Moore's law is here it's not about the idea of compressing things into tiny spaces. It's more about, you know, spreading them out. So you know, how big objects can I make? How well and how many kinds of functionalities I can compress into what we call, that's like a visionary thing. You see that it's an object which we call an ultimate, you know, integrated object. So if I can put in the actuators, I can put in the optical components or features, the microfluidics, electronics, all these things. So you could talk about it maybe in terms of number of components, a number of functionalities, and that's going to grow. And the other one is, and maybe we could count them. The other one is really about how big can we operate? How big things can we make? So I'll give you an idea of what people find really important, and there's a need for it, is Boeing, for example, wants to reduce the weight of their aircrafts altogether and the complexity. And they are dreaming about putting the wires literally within the panels of the airplane. So that means when you make the panels, it's got already the wiring in it. It's literally printed within the fabric of that component. And that means you do not require assembly. You should see how these people are putting together the harnesses. It's like a huge harness of thousands of cables. So so can I scale it to make an airplane? Can I that's a really interesting question. And I'm not sure I can give you the answer. But maybe we should think about what is that scenario? Is there a growth curve that we should predict?
Hi, this seems really cool technology. Could you talk a little bit about the commercialization model? In other words, is there a particular partner selected in this or that market? Are you seeking partners, or are you opening it up? Are there reference designs for people to glom onto? What are you guys planning in terms of commercialization?
So, it's important to emphasize, I alluded to it, that we are in the business of, our product is innovation at PARC. And so that means we help other people commercialize technology. So we have partners in all of those three segments. That means we're working with a number of chemical companies, material companies, who are in the business of developing portfolios of materials. And sometimes our business is to prove that a particular semiconductor material or sensor material actually works. So we print with them sensors, we print with them circuits, and the product for me is to provide a proof of principle to them, or maybe connect them to another party who is already in the business of making a consumer product where he really wants to make that gadget, sense something. So I've got clients in the material space, clients in the printing technology space, and clients in the consumer product space. And I can tell you the ideas are, so that's what's important. With these kind of projects, we put out ideas that people can respond to. And with these pilot projects that we're running, again, that facilitates that. So then the consumer product companies, NASA, I mean, one of the things you see there is JPL is asking us how we print a on-demand electronics manufacturing, like a mini printing lab up for the space station. So that's not, that's the beauty of that is that's not a product. I don't need to worry about the market size for that. That's a drive that is coming from, let's put it on space. But it's a wonderful pilot project. So I'm going through pilot projects that some of them lead to products right away. So the printed memory is something that our partner Thin Film Electronics is commercializing right now. So the beauty of that, and maybe that could go back to the idea of how you pivot, is so those guys were thinking of making high-density memory that was going to complete with flash. That didn't work out. But they then discovered, and that was a business innovation too, that you could actually usefully make 10 bits of memory as part of a packaging solution. So that's how we, so my product is helping those companies who bring pieces of the puzzle, and we also help them to connect those pieces of the puzzle. And step by step, we create value by, making these portfolios bigger, enabling the printed memory, enabling smart labels, helping NASA to come up with a vision of, of an on-demand printer.
And we're always looking for partners, so if anybody here is interested, please talk to us.
I will say that I started writing about PARC 2 years ago after I saw a presentation about this technology and the government funding a project to see helmets of soldiers in the field, whether they were hit by concussive blasts, how much
Smart
whatever
tape.
they took.
It was smart tape that you stuck on your
Thank
helmet.
you. To see, at what point they would have brain damage or, not be well. And that applicability to sports equipment and kids, that's a big issue today. And then the other one, I think Thin Film told me about, was about the temperature of packaging, such as meat. If it drops below a certain temperature and you go to the supermarket, you're not going to want to buy the package with the big green flashing or red flashing, don't buy this sensor in it. So those things I was told were sooner rather than later technologies. Right. I mean, in the case of the helmets, that's already here.
Yeah,
And in the case of the packaging, I believe Thin Film has already partnered with some big packaging company to try to bring that kind of sensor technology to food packaging labels, which as a consumer I would love to see, although I'd be kind of scared as to what the sensor is doing to my food. But that's because I'm paranoid.
They're on the outside of the packaging, so yeah.
Okay, somebody back there. Yeah.
I'm a medical device sensor guy, and I'd just like to bring in a little history that And my impression is that for a sensor to really find wide commercial application, there has to start with some large volume application. And examples are temperature measurements started with mercury thermometers, having mercury in them. You make millions, tens of millions of them, and then you can make them cheaply. Pressure sensors were $500 until they included them in medical device pressure sensors, bringing them down to a couple of dollars. Accelerometers were extremely expensive until we needed them for automobile safety purposes. And GPS used to be expensive until we can get it into a cell phone. And so what I'm encouraging you to think about is, what is the application in which you could find a first application that's really high volume, that drives your manufacturing process to be cheap enough to find lots of secondary applications. Yeah. And so I'm thinking the advantages you have, you probably can't compete in the flexible PC board, flexible PC circuit business, because they can make something this big probably cheaper than you can. And you probably, or I'm a medical device guy, and I'd say try to stay away from medical devices as long as you can. In a regulatory sense. But if you can find an application that will get you there without having to be contending with the FDA, that'd be a good thing. And so I'm trying to think of some application that takes advantage of the benefits you have. Are it can be quite complex, it can be pretty large, it can be flexible,
right.
It can be shock resistant because of the way you make it. And so search for an application like that that has a potentially high volume that will then get you into the other applications that you really want to be in.
Yeah. Thank you. We explored a lot of different stuff. A lot of what, like the Jana showed, or maybe Dan showed, the kind of hexagon with a bunch of little hexagons around it. Like each one of those is an area that we explored explicitly because we believed that there was a significant market in it. We picked this one because we thought it was a fun story, but we agree.
I know there are a lot more questions in the crowd, but we're already at 10 after 6. So if you could please stay, we'd like to open things up for open networking. Please bring your questions up to the panelists, who I'd like to thank greatly for being here and sharing their insights. And Connie, thank you for asking the provocative questions and not letting them sit in their laurels. So thank you very much.